So here's the rest of that worksheet. There's 2 and 3. Press pause if you need to study them more carefully. There's 4 and 5. We're going to skip page 2 of this worksheet. There's nothing new on it. It's just more of the same stuff, so we don't really need to do it. You're welcome to try it. Let's jump to the 3rd page. It's kind of the same thing. It wants you to sketch a possible f of x. It's not presented in table format, but it's the same type of information. So 2a, let's do a couple together. Let's do the first 2 together, and then I'll leave you with the rest of them. And then we got one more thing to do today. F prime is greater than 0. So what's that mean? F prime is positive, which means f is increasing. And that didn't have any restrictions on it, so apparently f is increasing the whole way for this graph. F double prime is negative. What's that mean? F is concave down. And again, apparently that's the whole way. So I need to be increasing and concave down the whole way. And f of 0 equals 2. Oh, it's nice when they give us a point. As a teacher, as a grader, I like it when they do that, because that way all our graphs at least are closer to the same, because everybody should be going through 0, 2. So I need to increase, concave down the whole way, and go through that point 0, 2. So increasing, concave down. Again, if you need to do the little graph piece, you just kind of think to yourself, not on the graph, but just increasing concave down looks like that, then maybe it helps to draw just a little piece of that graph, and then take that to this graph and increasing concave down. And again, there's still multiple ways you could draw that and be accurate. Sketch a possible graph. Question on that one? All right, part B. F prime greater than 0. So f is increasing when x is greater than -1. F prime equals 1. Oh, what's this mean? F prime equals 1 when x is less than 1. F prime equals 1. Horizontal would mean f prime is 0. What's f prime tell me about the graph? The slope. So if the slope is 1, and x is less than -1, so it's like that's a line when x is less than -1. A line with slope 1. F of -1 equals 0. Okay, that's my favorite information as a student and as a teacher. As a student, because it gives me something for sure. Like I know -1, 0 is now on the graph. Teacher perspective, it means we all have a similar graph. Some people will sort of check these off as they meet the criteria, especially as things get crazy. And then as x goes to infinity, f of x, the limit as x approaches infinity of f of x equals 2. What does that mean? Maybe it may mean it doesn't go to 2, but it means it sort of approaches 2. So I'm going to put an asymptote at y equals 2, because we're going to get closer and closer to 2. Alright, so left of 1, I have a line with slope of 1. So that's supposed to be a straight line right there with slope of 1. And then right of -1, It doesn't really say anything other than we're approaching infinity, or excuse me, we're approaching 2. So I guess I'll just sort of approach 2 like that. All right, I'm going to press pause. You try C and D, and then we'll move on to the last thing for today. Looking at C, f prime less than 0, so that means f is decreasing. F double prime greater than 0, so concave up. But all of that is less than 2. Decreasing concave up looks something like that. Y-intercept of 1. And when x is greater than 2, my function is equal to negative 1. So that's kind of weird, but that's all that means, is that the y value is negative 1 when x is greater than 2. And so I need to fit in a decreasing concave up curve through that point. So something like that. Part D. Let's see. I'm going to start with the point that makes the most sense. F of 0 is negative 1, so I can definitely put that on the graph. F prime of 0 equals 0, so that means there's a horizontal tangent line right there. Or the graph has a horizontal tangent line right there. It's always concave up. And then now I'm going to make sense of this stuff. F prime less than 0, so f is decreasing when x is less than 0. F is increasing when x is greater than 0. So decreasing and then increasing, but always concave up. Decreasing and then increasing, but always concave up. So something like that. And again, it's a possible graph, so if yours was a little bit steeper, that's fine. If yours was a little bit wider, that's fine too. All 3 of those graphs meet the criteria. So you'd be okay on any of those. All right, E and F will be homework. A little bit of a change of pace from what we were doing. It's still first derivative, second derivative, increasing, decreasing, concave up, concave down. But instead of giving you the table and having you make the graph, I'm giving you the equation. So we're going to back up a step. From the equation, you're going to create the table, and then from the table, you'll make the graph. So it is one step harder than what you were just doing. Kind of like what you were just doing was, hey, here's the table of information stuff. Use those 2 kind of tables to make a graph. Now we're going to back up a step from that. So let's start with x cubed plus 6x plus 9x. Job is to get through one full problem, and then your assignment will be the other side. I'll give you one more problem. X-intercepts, that would be where y equals 0. So I'm going to try to race through the algebra stuff because we all know algebra really well. Right? Let's factor out an x. Then I can factor what's left. So x equals 0 and x equals negative 3. But something's going on at negative 3. Do you remember what we call that and what that does? The double root. You remember how that affects the graph or what that does to the graph?
It's not like a relative.
Well, even before you got to calculus and knew the words relative max and min, I think you knew what a double root, how that looked on a graph. It's a bounce. Like, I don't know which way it bounces, but it's a bounce. Like, so it doesn't cross the axis there. It bounces up or bounces down. And so that does mean it's going to be a max or a min. Don't really know which one yet. Y-intercept, we set x equal to 0. That's an easy one. Asymptotes. Well, this is a polynomial. Polynomials don't have asymptotes. So, no on that. F prime. 3x squared plus 12x plus 9. This is where some people might opt for the quadratic formula. I don't know why they would do that, though. It would be much easier to factor out 3. Well, I guess I should back up and say where we're going with this. We want to do the first derivative stuff with this. Set it equal to 0, find the max and min, find increasing and decreasing, all of that, the first derivative things. So x plus 3 and x plus 1. So negative 3 and negative 1 are critical points. Something's going on at negative 3 and negative 1. I think a number line would be helpful. Didn't leave much room for that number line. Got some test values. Where am I going to put those test values? Original, first derivative, or second derivative? First derivative, because I want to know if we're increasing and decreasing. So I'm going to do 0 first, because that's the easiest one to plug in. So f prime is positive. Let's make sure we label what we're doing here. F prime is positive. That means f is increasing. If I plug in negative 2, again, preferably the factored form, but it doesn't have to be. We get a positive times a negative. So that's a negative. So f is decreasing. And if I plug in negative 4, I get negative negative is a positive. So that would mean f is increasing. So let's sort of take this information and put it on this table. Interval, negative infinity to negative 3, negative 3 to negative 1, negative 1 to infinity. This worksheet is like a blank that can be used for anything. I'm trying to think of the word I'm looking for there. But so not everything is going to be filled out on this table. This is just a word escapes me what I'm trying to say. We tested negative 4, like a blueprint, or it's still not the word I'm looking for, but negative 2 and 0 are our test values. The sign of f prime was plus minus plus. The conclusion, like why we did this, how that helps us, is that f is increasing, f is decreasing, f is increasing. So where is there a relative max? Negative 3. How did you know that? F prime changes positive to negative. And a relative min, negative 1. And same, well, not exactly the same reason, sort of the opposite reason. F prime changes negative to positive. Now, that's not wrong, but the reason I'm doing this is to get to a graph. So I have an x value, but if I want to put that on the graph, what else do I need? It'd be helpful to have a y value. So I need to figure out what f of negative 3 is so that I can put that point on the graph. Like knowing where the max is helpful, but if I want to graph it, I need to know its y value. Same thing with the min. If I plug in negative 3, I get 0. Did you plug it in, or did you just find that? Okay. That works. If we were really paying attention, we might have noticed that negative 3, 0 was already a point on our graph. So it turns out that that's a max. negative 1. Let's see, that would be negative 1 plus 6 minus 9. That would be negative 4. I should start putting this stuff on the graph since that's where we're headed. Let's see, 0, 0 was a point. Negative 3, 0 was a point, an intercept, but also happened to be a max. And then negative 1, negative 4 is a min. I don't have to label them, but when it comes to graphing, it might be helpful. And we are increasing, decreasing, increasing. But I want to do concavity to get my picture better here. So second derivative stuff. So same process, but with the second derivative. And because it's a polynomial, my derivatives are getting easier and easier to deal with. So if we set the second derivative equal to 0, we get negative 2. So now I feel like a little bit better about what's going on. Maybe I can start filling in the table. Test value negative 3, test value 0. If I plug in negative 3, what do I get for f double prime? Plug in negative 3. I get negative. I don't care what value it is. I care that it's negative. If I plug in 0, it's the easy one. I get 12, positive. So my conclusion then is f is concave down, f is concave up. So where is there a point of inflection? Negative 2, comma, whatever negative 2 is when I plug it in. Negative 8 plus 24 minus 18. I'm plugging into f because I want where the function is now. So that would be negative 26, negative 2. Negative 2, negative 2. Oh, that fits really well with my with what I already have. And I think we can ignore the rest of this stuff. We got enough now to graph it. So we are concave down right there, concave up after that, and we've got some points to hit. So there's my graph with 3 minutes to spare. No, don't worry about that. On the back, here's the one I want you to graph. So do all the same steps with x cubed plus 6x squared plus 12x plus 7. Finding an x-intercept is kind of tricky for one like that, so I'll just spot you the x-intercept is negative 1, 0. And then follow the same steps that we did on the last one and graph it. So we have 3 homework problems, right? 3 graphs. One where we give you the table, 2 where we gave you the table and information, 1 where we give you this equation and ask you to do all the stuff on it. So continuing to make those connections between f prime, f double prime.